Welcome to Thread Notification Wait and Notify module. I'm Buddha from Pluralsight. During this course, I'm going to demonstrate how threads can work, communicate, and coordinate with each other. We will see how to use notify and wait methods and use them to solve a ping pong threads problem. Let's first understand why notification based approach is important. Imagine a server producing data and clients like our PC and laptop that need to consume it. An example would be Gmail and Outlook. One way to receive data is that the client can poll at regular intervals to check if there is new data for consumption. The process gets repeated at regular intervals and is called polling. The problem with polling is that the server keeps responding to the polling request when it can actually perform useful function of producing the data. If number of clients grow, there can be too many poll requests. This leads to unnecessary data transfer, congesting the available bandwidth. So solving the producer-consumer problem using polling mechanisms is not efficient. Alternatively, we can use notification-based approach. In this approach, consumers will register themselves with the producer, while servers solely concentrate on producing the data. Once the data is ready, server opens a connection and sends the message back to clients. This saves CPU time for both server and client. Communication and data transfer happens only when it is necessary. Hence, this approach is more efficient than polling. We'll be learning how to implement the notification mechanism in threads to solve a ping pong problem that forms the basic understanding required for solving complex problems. But let's revise what threads are. Each application running in our computer is a process. If we look closely into an individual process, we see that multiple subprocesses are running in parallel. While the user is typing in a document, the word process is simultaneously doing a spell check. Processes achieve this concurrency by means of threads. Threads are independent parts of execution. You might be wondering how the computer can run multiple threads simultaneously, even when a typical computer has only one processor that can perform only one calculation at a time. In reality, threads run one at a time. However, they are switched automatically at high speed to create an illusion of concurrency. Here is a simple thread that prints numbers from 0 to 100. The simple thread extends thread class and overridden run method contains implementation of what needs to be done when the thread is started. To start the thread, we have to create an instance of the thread class we created earlier and call the start method. Once the thread is started, main method continues execution without waiting for the thread to finish its run method. Even the main method execution happens in a thread. We call it main thread. Both threads will be running simultaneously. However, it doesn't automatically guarantee equal share of CPU time for each thread. The way they are designed, there is no way for us to control how much time each thread gets. Let's look at it in action. Here is a simple thread, extending thread class and overriding run method. It prints 0 to 100 preceded by t colon. And simple runner has a main method that takes care of starting the thread. In line number 5, we have created object of simple thread and t.start will start the thread. Once the thread has been started, main method won't wait for the thread to finish. It continues to print from 100 to 0 in descending order preceded by m colon. T.join will ensure that main method waits until simple thread finishes its execution. Let's run this and see what the output is. We see that the first chance has been given to the thread and it printed around 10 numbers, and then main method printed 1, and then again thread came into the picture and it printed a couple of numbers and m got only one number, and this way it has distributed. As you can see, this is definitely not a fair share. If we run this again, we cannot guarantee to see the same output. Now if you see, it started with main method and thread has printed one number and then main method one number and then thread printed a couple of numbers. If we run it again, the output will again be different. Now let's understand what this ping pong threads problem is. Imagine two threads. Thread 1 prints out 1 repeatedly whenever it gets to run. Thread 2 does the same except that it prints 2's. Now here is the problem to solve. We have to design these threads in such a way that when these threads are started concurrently, they should produce an output of alternate 1's and 2's. As we have seen in the previous demo, in their simplest form, we can't control how these threads should relinquish and let other threads run. If we simply run as in the previous form, the output can be like this, or like this, or it can even be like this. However, what we need is exactly 1 1 followed by 1 2. Let's look into how this can be solved. One solution that comes to our mind is If a thread sleeps for a brief period after every time it prints a number, other thread will get a chance to print and sleep. However, the problem is how long should each thread sleep? Do we say 1 second or 10 milliseconds? It can range from not being enough to too long to make the process run slower than required. Another problem is that thread.sleep doesn't make any guarantees. Thread may wake up before or after the time provided. This may result in unpredictable output purely based on when it is executed. Neither of these threads know how long to wait, so let's rule this approach out. However, a better solution lies close to the previous approach. Instead of sleeping for certain milliseconds, we can modify the approach so that each thread will notify other thread before going to sleep, and the notified thread gets awakened and continues to do its job. For this process of notifying other threads, we use notify method. However, as we have already a method named sleep that doesn't have mechanism to get notified, we use wait method to achieve this purpose of going to a special kind of sleep where the lock of the object is relinquished. But there is still a problem. How does thread 1 know which thread to notify? There can be many threads running simultaneously on unrelated tasks. In order for a thread to wake another thread directly, we may be tempted to maintain the reference of other thread to be woken up. However, this is not a good practice. The answer lies in the way notification mechanism is implemented to work alongside of synchronization. Synchronization is a process of locking an object so that it is available only to that thread. All the threads that work in coordination will share a single object for synchronizing. This is the reason why notify and wait methods are actually implemented on object class. Instead of thread bothering to wake another thread up, it will simply notify the object, which in turn wakes up another thread waiting to acquire lock from waiting state. To put in other words, it works like this. A thread enters a synchronized block acquiring lock and preventing other threads from acquiring lock on the same object. Meanwhile, the second thread starts running but can't enter the synchronized block. The first thread performs the necessary work and releases the lock temporarily without leaving the synchronized block and requests the object to notify other threads waiting on the same object. Once the notification is gone, the first thread waits and second thread can acquire lock on that object. The same approach is followed by the second thread. The cycle repeats until both threads complete their work and leave the synchronized block. Let's look at it practically. Here is our thread 1, which simply prints ones, and here is our thread 2, which simply prints twos. And the runner class we have created in such a way that it starts both of the threads at a time. And now, to get the output that we anticipated, that is alternate ones and twos, if we run this in the same form, we won't be getting that output because as you have seen earlier, we don't have control as to when the threads will be switching in and out of context. So if we run this, we may be getting entirely different outputs every time we run it. Now, in order for us to be able to use the notify and wait mechanism to get the output that we wanted, first thing that we have to do is we have to synchronize on a common object. We can synchronize by using this synchronized keyword, and I have created a static object called lock that we can use to synchronize it on. We are synchronizing this thread 1 and runner.clock. We have to do the same thing on thread 2 as well. Once we have synchronized, now we will be able to successfully wait and notify. The wait and notify methods are actually implemented on the object that is getting locked. So when we say runner.clock.notify, all the other threads that are waiting for acquiring this lock will be notified. Once we have notified, we have to wait until we get re-notified. So let's put a time limit of 1 second, and we also have to put this in a try catch block so that any exception that is caught will be inside the loop. We don't have to do anything, it just wakes up and we can simply ignore it. And the same thing has to be done in thread 2 as well. This is it. So now, as you see, we have notified and we are waiting, and we are doing the same thing in every thread. If we run this now, we should be able to see the output that we expected, which is an alternative ones and twos. In this course, we have understood how threads notify each other by synchronizing on one object by utilizing wait and notify methods. We have solved a ping pong problem using these wait and notify methods and the notification approach. Thank you.